See, we already calculated previously that the complexity, burst time complexity from taking sum from x to y is big of n. Am I not audible or?
Sir, they are writing at y minus x plus 1.
Like we already calculated the worst complexity. See, you can take y minus x minus 1, but these two are again your those variables. So you cannot take complexity of like y minus x. You don't even know what y and x will be. So you have to take the worst complexity, which is like we calculated of n, because in the worst case x will be 0 and y will be n minus 1. So this code, this for loop has a worst complexity of n. So this whole y will be like I will run for q times. So this will be of q into n, because for every query this has a worst complexity of n, big of n. Is this time complexity clear?
Yes, sir. Sir, but the code is like it is not fully clear. Like it is a little confusing.
Just a second. Which part is not clear actually?
So the
Like
middle
this
part, like that
indentation
Q
or
part comes now. This part.
this part? The while q minus minus that part?
Yes, sir. Sir, like it was a little fast, so like you typed very fast, so that's
Okay.
why.
So see what we are. So the question is clear to you. See, there is an array. First of all, its size will be given, where elements will be given, number of queries will be given. Then for each query there will be two integers x and y. So as we done previously, you will have to calculate the sum from xth index to yth index. So what we are doing is, initially we just scanned the array here. Till now it is just the scanning of the array, which is done in of n. So nothing to that. Then we just scanned our queries in queues, c in q. For while q minus minus, we took two integers int x and y, scanned those integers, took our variable int answer equals 0. In this for loop, we just computed our answer, which just adds all the values from the xth index to yth index, and we just print that answer. Now is it clear?
Yes, sir. It is more clear, but sir, like Q minus minus will stop at 0. Sir, but
Like three queries, it will run for 3, 2, 1, and just stop.
sir, but integers can be negative, na? So then Q will get minus and it will continue, na?
No.
No, 0 is considered false. When it's false, the while loop will break.
See, while this q minus minus, it's like this 0 integer is a false integer, and any other integer is like true. So if
Sir,
in the bracket the value is 3 or 2 or 1, that will like continue. Okay, it's good, it's true value, the while loop will go on. But as soon as it reaches 0, this will be like treated as a false value by the while loop, and the while loop will break. Okay, it's similar to like for int, like when you write a reverse loop for int I equals to, like, let's say 3, I greater than equal to 0, I minus minus. So it's a similar thing to that, except we are not taking like int I again, or like initializing some for loop. We are taking a while loop. Okay, so this
okay,
code
sir.
is clear to everyone.
Sir, and
What is this
this
code doing? And
this CN we will have to enter 3 times ourselves, or like the data entered above is there, like here in C in.
uh, no, see, we are in queue. So the that your sample input, like input will already give you some, like an integer already there, how many queries are going to be there. It is not, this is not a constant. Q equals to 3 is not a constant, it's a variable. I already told you its limit is 10 to the power 5.
Okay, sir, now fully understood.
Oh, okay, so coming to the time complexity, I told you that the time complexity of this for loop of just adding the sum from x to y is like big of n. Okay, so for while q minus minus, another like for q times this for loop is gonna be executed. So big O q into n. Okay, so is this time complexity clear to everyone? Big O q into n. Everyone, I mean like all the like 30 people in here. Okay, so this is q into n. So if we just like check q, the range of q is 10 to the power 5 and n is also 10 to the power 5. So what will be q into n? So it will be of 10 to the power 5 into 10 to the power 5. So generally, so around you will be using 10 to the power 10 iterations. Okay, so as discussed previously, to accept some quotient, your iterations should be less than equals to 10 to the power 8. But we are using around 10 to the power 10 iterations. So this code will be a time limit exceeded. Is it clear why it will be a time limit exceeded code? So, so we actually have to think of some optimization. Think of something like we can reduce some for loop here. We can reduce some iterations here, so that we get a result in 10 to the power 8.
Sir, so this one will
In
be an error.
realization of n or of q.
This one will be an error.
Oh, yes. In like some cases will pass, which will be having less number of iterations because there will be less constraints on them. But some tasks, some inputs will definitely fail, which will give you time limit exceeded because we are using 10 to the power 10 iterations here. Okay.
Yes,
So,
sir.
and an idea how we can find the sum in like let's say 10 to the power 5 queries. Let me just give you something like in any query we will be computing the sum in of 1. We computed in every query we computed sum taking of n. Okay, we wrote a for loop. I give you a hint that we'll be doing it in of 1. So any idea how it will be done? A use function someone has written. Even if you like uh, like treat like use some write function here, and you will be taking these 2 lines of code and implementing in that function. It won't change time complexity. That function will also run for of n times, and then again for q queries it will run for of n into q. Defining a function doesn't make that it will now run in of one time. So okay, so let's discuss one by one how we can. So now this comes down to thing known as pre-computation. Okay, so just let me just take, so we'll have to go through quite a lot of things. Let's say this is your array. Okay, so let's say anything 1, let's say 3, 5, 8, 2, 6, 0, 9, 11, and up to so on. This is your array. So there will be queries like from this x to sum this y, find me the sum. Okay, so this sum from x to y, can it also be represented as sum of let's say 0th index to y minus sum from 0th index to x minus 1. See this thing? I'm saying that the sum from x to y can
Yes, sir.
it be represented as sum from 0 to y, 0 indexes to y indexes minus sum from 0 to x minus 1. Let's say take this whole sum and subtract this 1, this 3 here. So you will get the sum of the remaining part. Is it correct?
Yes, sir.
Okay. So this is our statement that sum from x to y can also be sum from 0 to y minus sum from 0 to x minus 1. So say that I have an array stored, some another array. So what am I gonna do is that so let's say the indexes of this array, let's name it as, let's say, BR array. Okay, so this is a BR array. So yeah, so let's say I define that the BR array will contain the sum of the above array till some index. Let's say if this is the 0th index, then BR array will contain the sum till this index. So let's say this is 1. So BR array will contain sum till 0th index of the AR array. So let's say this was 1, so this was 1. Okay. So let's say this is 3. So the first index of the BR array will contain the sum from 0 till nth index of the AR array. So 1 plus. So let's say now this is the second index of the BR array, and I'll say that now this will contain the sum till this index of this array. So 1 plus 3 plus 5 is 9, and let's say 17 this. Like you talk about cumulative sum, so this is the cumulative sum up to so on. Is this array clear how we came to this array? I am saying that the BR array is nothing but its indexes are the sum of the from 0th to that index of the AR array. Let's say I can write here the BRI is nothing but sum from 0 to ith index of AR array. Is it clear? Is it clear that we have an array and we make a sum array such that its indexes represent sum from 0 to ith index of AR array. Okay, so now as we done earlier that the sum from x to y can be represented as sum from 0 to y minus sum to 0 to x minus 1. So let's say you have computed this BR array. We'll discuss how we computed this, like on code, how do you compute this. But now you can directly write that whenever query of x and y comes, you can directly write this thing, isn't it? Let's say BR y minus BR of x minus 1. This will be sum from x to y. Okay, is this thing clear? Since we stored sums till till the indexes in our BR array, so we can the statement we formulated earlier, sum from 0 to x minus 1, we can then write this thing as BR of y minus BR x minus 1. Is this thing clear?
Sir, but how will this like reduce the power below 10 to the power 8?
Yeah, because how much time does it take to get a value from an array? If you already have this array, assume you already have this array. Let's say you have an int AR. So see this thing, scanning or even utilizing some value of AR is of constant time, isn't it? Let's say you want to use AR0 value, like you you want to use some 1 second, let's say I have an integer AR already, let's say it has values, and I write int A equals to AR0 plus AR1, the sum of the first two numbers in the array. How much time will this statement take? Isn't it it's of 1, because this is stored, like we don't have to any write, like this statement is of 1 na, because accessing the elements from the array doesn't take any time. Is it clear? Like first of all, tell me that this statement is clear, that this is of 1.
O1.
Like we denote of n, so of 1 is our unit. I said you that the unit statements, we treat them as of 1, and with respect to our unit statement we have discussed the proportionality of n. Okay, so this statement is of 1 because we are assessing array elements in here, and assessing array elements doesn't require any computation or any time, so directly the statement is of 1. So is this clear?
Yes, sir.
Like I am adding two numbers, I'm adding two numbers from the array, and like AR0, and getting the value of AR0 doesn't require any time, so this is of 1. So now if you, let's assume that you already have this BR array, then does subtracting these two values will consume any time, or will this be of 1?
No, sir, it
Assume
will
you
take some
already have
time.
BR array and you are subtracting BRY minus BRX minus 1. Y and X are indexes. So won't be any time issues. Okay. So this statement here is now an of 1 statement.
Sir, so the timing complexity of this function is O of 1. Like this big function, it is
No,
just O of 1.
of like this is of 1, but when you will be writing for every query,
Okay, it will get
you will
multiplied.
be writing that BRY minus BRX minus 1. So that will be of Q into 1, which will be of Q. So from 10 to the power 10 iterations, it will come down to 10 to the power 5 iterations.
Sir, in constructing that down array, we will need some time complexity.
What?
Here,
Constructing the BR array. Yes, definitely there will be some time for this. We'll discuss that. But I am just telling you that assume you already have this BR array, which is the sum from 0 to ith index. That BRI denotes the sum from 0 to ith index. Now, if I am doing BRY minus BRX minus 1, that is of 1. I'm taking that, assume that we already have BR array. So in this, like while Q minus minus, let's just write it again, that while Q minus minus 1 would be like you take two numbers int xy, scan both the numbers, and let's say your answer is, you do not have to traverse this time your for loop, because this will be this minus 1 cout answer n. Okay, is it clear? You just have to check one edge case. If x is 0, x minus 1 is a negative number, so alright, you can just
Sir, and BR, what is the full form?
what
BR, what is it?
no, like for like I have just taken an array. Let's say you denote an array as AR, and there is another array as a BR. This
Okay, sir.
capital BR is a BR. Yes. Okay, that's the thing. So just take considering this thing, that let's say this is an edge case that might get you wrong, because if x equals 0, x minus 1 is an index. Okay, so if the your input ask you from 0 to some y, obviously that is just this answer, this the value at index y of the BR array. Okay, you don't have to now subtract subtract something because you cannot, because there is nothing at -1 index. Is this clear? Now, is this loop clear? Just assume you already have BR array. Now, is this while q minus minus is clear? Everything under while q minus minus.
Yes, sir.
Sir, x
So,
factorial
this-
equal to 0, like x not equal to 0, that is. Oh,
When
huh.
x is not equal to 0, x minus 1 will definitely be a positive integer. Maybe 0, maybe anything, maybe greater than equal to 0. So x minus 1 will be greater than equal to 0 if x is not equal to 0. Otherwise, it is 0. We cannot, like BR x minus 1, x minus 1 will be a negative integer. We cannot go beyond
Yes, sir,
0
yes, sir.
in an array. So that will be a segmentation fault. So that's why this thing. Okay. So this subtraction here or assessing this is an off-on directly. We know assessing some value from array is off-on. So this whole loop comes down to big O Q. Okay. So now this thing is resolved because Q is 10 to the power 5 range. So big O 10 to the power 5 range. We have our code running. But we'll still have to compute BR array. Let's see how we can compute the BR array. Okay. So we can have different approaches to this as well. See, let's say you need to write BR array here. Let's say what will be the size of BR array if the size of the current array is n. Let's say your array n. What will be the size of the BR array? Someone just tell me.
N only.
Okay, yeah, n only, because we have to calculate sum till n indexes only. Okay. So what can we do that for int I equals 0, I less than n, I plus plus. Okay. There is one simple way to do this. See, if I just take j equals 0, j less than equals to I, j plus plus. See what this two for loops do. So let's say for I equals 0 to I equals n, I less than n, I have to fill the BRI value. Okay. Now what is the BRI value? Sum from 0 to that index of the ARJ. So I just did this thing, sum from 0 to sum till ith index, this thing, and I just denoted BRI equals to sum. Is this able to calculate my BR array? Just tell me, is this able to calculate my BR array? Is this correct? Just ignore the time complexity, but just tell me, will it compute the correct BR array what we aim for? So this will calculate, but see again the time complexity will be, I told you, like
Sir, one
again,
second.
0 plus 1.
Sir, I was greater than j, na? So I equal to 0 and I less than equal to j. That we'll write or we'll write j?
What?
Here below we have written for int j equal to 0. I think instead of j I should come, na?
Why? Again, you already used I here. Again, you want to use I in this too. Like BRI was the sum from 0 to ith index of AR of the array AR. So I'm just taking, like when I am at some ith position, I am just taking a for loop from 0 to I and calculating its sum and storing that sum in ith index.
Sir, no, sir, this one it is a little confusing. Sir, I is used twice, sir, in second loop. So I is used and again it is used with j. No, sir, not understood fully, sir.
No, I am not talking about time complexity. It will be offense curve, but let's discuss it later. But is it computing correct BR array? I'm asking that. Let's say, see, Let's just take some again example. Let's say arrays 1, 2, 3, 4. When I is 0, j starts from 0 less than equal to I. So j goes to 0 only. So sum plus equals to arj, sum equals to 1. So br of 0 equals to 1 for I equals to 0. Is it clear for I equals to 0? I'm talking about I equals to 0. This inner loop will run for only one time and will denote sum equals to 1 and br0 will be initialized to 1.
Yes, sir.
Sir, AR or BR?
So
Now it's little.
br array is used to store the sum. AR array is the original in which now the sum is doing the addition of the AR value. Now sum plus equals to mean sum equals to sum plus ARJ. I'm not getting what is confusing you here. For
Just think of like you need to compute the sum from 0th index to ith index, right? And then think like this in boxing part after sum equals to 0 and this for loop. Is it working correct for that? Like you need to compute sum from 0th index to ith index. Is the second for loop working correct for that?
Yes, got it. I'm getting it now.
Sir, sum plus, I have a small doubt, sir. Sum plus equal to AR, J means
sum
AR
equals to sum.
sum plus.
See this statement. One second. See this statement. See this statement. Sum plus equals to ARJ is sum equals to sum plus AR. Is it clear now?
Yes, sir.
Okay. So just like you can write sum equals sum plus ARJ as sum plus equals to ARJ. Done and the same thing. Now for the second iteration when I equals to 2, when I equals 1, 1. So j runs from 0 to 1 and sum comes 1 plus 2 as 3 and br1 is stored as 3. Is it clear for the first iteration? Is it clear for the like next iteration for I equals to 1? Is it a yes or no, please?
Yes, sir.
Sir,
Oh, okay.
it is a little complicated. Like, these two you explained that is clear, but overall the loop, like, it is little complicated.
See, you did sum from x to y.
Yes, sir.
Okay, so let's say j equals to x, j less than equals to y. Just replace 0 with x and I with y. What this loop will give? Sum from x to y.
Yes, sir.
No, so now I am saying x is 0 and y is I. What will this loop give? Sum
From 0 to I.
So what I am storing in BRI? That sum.
Okay, sir.
Okay, so again, now what will be the time complexity of this whole thing? 1 plus 2 plus 3 till n again of n square.
Yes, sir.
Because the outer limit has n times, inner loop is 3 n square n times, like we did earlier. So of n square will be there. Again, n was 10 to the power 5, again 10 to the power 10 iterations. Again, we are stuck in the time complexity, isn't it?
Yes, sir. We are again stuck. Like, again it's n square, then it will be 10 to the power 10.
Now, next hypothesis, next claim. Let's say we made one statement of the sum. Now we make another statement of the sum. Now it is that b. Let's say denote bri as sum. But what was bri minus 1? Bri minus 1 was the sum from the 0 to I minus 1 index. So what has happened in the ith BRI? We are adding just one another number. So we don't need to iterate for all of the for loops. So we can also do thing like this also. No? See this thing. What we were doing that we were going from 0 to I, again calculating the sum. But let's say you are at ith index. You want to calculate BR value for the ith index. But you already know the value for the I minus 1th index. You know, okay. So just so the difference from the I minus 1 to I is just an addition of the ARI value. So can I write this for loop instead? Can I write this statement instead of this for loop that says that the BRI is nothing but BRI minus 1 plus ARI?
Yes, sir.
Yes. So what will be the time complexity of this statement?
1.
Of 1, because it's assessing array elements only. Okay. So now let's just write the final code, which is for n I equals 0, I n I plus plus. So let me just denote when you denote brn. So we note br0 will be ar0 because that will be sum till 0th index. Let's start with the first index and we'll say that bri is nothing but bri minus 1 and just add an ari to it. Now just look over this portion and look over this code. So this was of n square thing and this has now reduced to of n. Now this is simpler thing. Okay, is this clear now why this thing is valid and how we have used it here? How is it calculating the sum, the BR array? Is it clear?
Yes, sir.
Okay, sir.
Is it clear to everyone? Need out? So after calculating this thing BR array, now you will scan your queries and do this thing. Where is it? Yeah, this thing. Okay. After going over that thing, now you will do this thing. So this will be, so the total time complexity of your code will be, see this was calculated in of n. So the total will be of n plus of q. So you can actually write this as equivalent to of n plus q. Okay, proportional to this. So what, or you can equivalently write this to as big O maximum of n comma q, which will be 10 to the power 5 at max. So now the time complexity and the code is clear. How we made a code of q into n and then we optimized it. This technique is called pre-computation. We are pre-computing the sums here. This technique is called pre-computation technique. So we are pre-computing the sums till ith index and using that to solve our queries. So that's how from of n into q, which will be giving us time complexity, we derive to a solution of maximum of n comma q. Is this thing clear?
Sir, I have a small doubt, sir. In previous method, while we are constructing BR array, you said that we will get time complexity as n square.
Yes.
But I am getting n square by 2.
Yeah, I already told that these things of let's say 2 into n or like of n by 2 or let's say you get n by 3, these don't matter much because these are not changing the order. Let's say 10 to the power 5 by 3. Okay, it will be around 10 to the power 4 or 10 to the power 5 again, isn't it? So this big O is a proportionality constant. Even if you get something like of n square by 2, that still means that the thing is proportional to of n square.
Yes, sir. But actually, I'm considering time complexity will be n square by 2.
See, time complexity in big O notation is a proportionality thing. We discuss about n square. We don't say it n square by 2. That it's one and the same thing. So like when you are looking at the code in your mind, you should treat it as n squares. You don't have to actually like exactly type like it will be 4n square by 3 plus something. You should just know that it's n square. Is it going to pass or is it not going to pass?
Okay, sir.
Those constants associated with n unless these are as big as n won't affect that much. Until you write something like of 1000 to n something like this, it will affect now because 10 to 10 to the power 3 is equivalent to like n. Now this will affect your code, but some constants such as 2, 3, 10, 20 won't affect your time complexity overall. Something like 4n square by 3 won't be like anything, like it will be same as of n square. Now here this constant, it does nothing to your time complexity. Main is your proportionality variable.
Okay.
Okay, so this was pre-computation technique, one of the methods. After this, like further we'll be doing in the next class, I think. Obviously the time has exceeded, so we'll be doing things later on. Okay.
Okay, sir, can you send a PDF form of this?